Let's take a look at using the Read API to pull data from a Canary Historian and publish it perhaps to a third-party application. To begin, if we take a look at the views on our Canary Historian for this demo, you'll see that there is a traditional historical archive view. My machine name is Canary Historian. I have 4 data sets, 3 of which have a generic data set and then a number, name, and then 1 full of diagnostic tags. Each of these 3 data sets have the same 3 identical tags: an alarm tag, a flow tag, and a status tag. The status tag has a serial. The flow tag is a double, maybe it's a float. Actually integer. And then the alarm tag is a boolean. Additionally, we created a virtual view. We created some rules that grouped the pumps by 3 different instance counts. So that's a pump, and then each pump has 3 generic tag names: alarm, flow, and status. All right. Documentation can be found by going to readapi.canarylabs.com, and each of the gets or posts are available here. For instance, if we dig into the get user token call, you'll see that there's a usage. There are parameters available. There is an example of how to frame the request, and then there's an example of the response. I'm going to be using Postman to illustrate all of the different calls that you can make and how you should use them. My Postman environment is currently set up where I am connected to the Canary machine on my network. For anonymous, I'm using port 55235, and for secure, I'm using port 55236. Additionally, we have some variables for our live data token, our user token, and continuation that we can call here. All right, so the very first thing you'll want to do if making a request is to establish a user token. If we take a look at the body, I am making my call up top, which is /get user token. And here we've named our application training demo, and we've set a parameter for Eastern Standard Time. So if I send this, I'm going to return a status code of good, no errors, and I'm going to create a user token. Now that user token will persist for 5 minutes and will release automatically after 5 minutes if I have not made any other calls inside of that window. Additionally, if I did want to take a look at some of the other time zones, I could use the get time zones call. And we'll just return all of the different time zones that you could call as part of your establishing of a token. All right, the next thing I would likely want to do is browse the nodes. When I'm browsing the nodes, I can leave the path open, just the double quote, and that's going to return both of my known nodes, both Canary Historian and pumps. So Canary Historian, which represents the historical archive, pumps, which represents one of my virtual views. The next thing I can do is browse for tags. I have several parameters that I can use when I'm browsing for tags. We'll go through each of these just a bit. Path allows me to leave it open. If I leave the path open, it's going to return every single tag inside of the system. Deep means how do I want to handle hierarchy? Do I want to continue down through multiple levels of hierarchy, or do I want to stop at the first break? We'll talk more about this here in a second. The search option allows me to search and do a filter to return tags that contain a certain string. And then I have the max size, which allows me to choose how many results I get. So let's start by setting max size to 200, and we'll just see what comes back. All right, as you can see, all of my tags are listed. Dataset 1, 3 tags, 2, 3 tags, and dataset 3 has 3 tags. And then we have a lot of diagnostic tags that are system tags. And then my second view, pumps, is showing me alarm, flow, and status for each of the 3 pumps. So let's start by taking a look at what would happen if we use pump inside of the search field. You can see that we only get tags back at that point that have pump in the name, and that could be anywhere in the name. Now we could also say, show me only Canary Historian, this is my capital, as the beginning of the path, and pump, and then I'll get only Canary Historian tags. And likewise, if I say set the max size to just 6, we won't pick up anything out of dataset 3 because that's tag number 7, 8, and 9. So this is a helpful tool with helpful parameters to be able to really select a custom grouping of tags. Let's take a look at the deep portion here. If I look at the diagnostics dataset only, you'll see that I have multiple pieces of hierarchy in my tag paths. So Canary uses the dot symbol to establish hierarchy. And if we look at all of these tags, you'll see that every one of them has some type of hierarchy structure after diagnostics, except for the very first tag, admin request per second. There is not a secondary piece of data in that tag name. So if I come here and set this to false, I will only get one tag back, and that's admin requests per second. So another helpful tool to be able to limit your return. Now additionally, I can come in here and ask just for my virtual view tags, which were pumps. And now I've got those pumps. I could also say just show me pump 2 by using 2 in search. And now I've got pump 2. So I'm going to go ahead and copy that group of tags. Now programmatically, you would isolate your tag groups and build your tag list by using this call. The next thing that we would want to take a look at would be how to get properties around these tags. So that's the get tag properties call. And we'll go ahead and do a demo on that. And what we return for each of those 3 tags is all of the metadata that's available inside of the system. So what was the source item ID? This is a virtual view, which means that we are aliasing the tag name and potentially providing new structure inside of the virtual view. This tells me where in the historian I've linked this tag to. We have a description field, whether default high scale or low scale has any data, what our sample interval is, in this case 30,000 milliseconds or 30 seconds, the data type, and then some other data. We're using a data generation service in order to provide these tags, and that's what this metadata represents. Okay, let's talk about how we actually pull timestamps and values. And we can use the get tag data or the get live data calls to do that. There's a difference between get tag data and get live data. Get tag data has 3 different use cases: to pull the last known value of a tag, to pull a group of raw data values of a tag between some type of a hard stop start time and end time, or to pull aggregated data process data for a tag or group of tags based on some type of interval time. So that's the get tag data. Every time we want a data value or a group of values, we need to call get tag data. Now there's another way to get data values, and that's get live data. Get live data is going to have a slightly different use case. It's going to allow me to make a call and get the last known value of a tag or a group of tags, and then make a future call at a later time and get all of the updated values for that tag or that group of tags. So let's start with the get tag data, and you'll see there's a large number of parameters, and whether we are asking for last value, for raw data, or for process data all depends on which of these parameters we use. So in its most simplest form, we can use get tag data to get the last value for a group of tags. Let's start with that. So in my call, all I need to do is provide my group of tags. And what I would expect to see would be a timestamp and a value for each of my 3 tags. This is the last known timestamp for the alarm tag, the flow tag, and the status tag. Flow changes every second, so if I ask for a new value, I should see a new value. Currently, I think I have the alarm and the status tag only updating once every 30 seconds. So I won't see too many changes there, but about once a second, I should see a change on my flow tag. And that's working. Now there's other parameters that I can add here. If I'd like to add another parameter, I just need to add a comma. And then we'll do, how about quality score? Include quality, and we'll set that to true. So now I have not just the timestamp. Notice that the timestamp does have my UTC shift in it. But I also have my value, in this case a Boolean, and my quality score, a 192. This brings us to another call, get qualities. And I can use get qualities to look up specific quality scores. So if I get a quality code, say, of a 192, a 32768, and a 20, and I want to know what those represent, there's the call and there's the return. So a 192 is a good score. A 32768 would be considered a no data value, and a 20 is a bad last known value. Let's talk here briefly about the difference between, say, a 192, a 0, and a 32768, where 192 represents generic good, 0 represents generic bad, and those are your standard OPC data qualities. Within Canary, if we don't have a response from a tag, meaning perhaps our sender session has dropped, we no longer have connectivity to the data collector, we will immediately write a no data value or a 32768 as the quality and write no data as the value. So that's what that represents inside of Canary's world. Okay, so that covers our get last value for its most generic form. We can also very easily transform this request into a raw data request. And so instead of just asking for, or I should say maybe a group of raw data values for each tag, not just the last known raw data value. So all I would have to do is really add a start time here, and we can make the start time a anchored date time if we wanted. So we could say 2020, today is the 5th, and we could ask for it from, I don't know, let's just go from, one second, let's go from, that's about 3:45 here, so what would that be? That would be 15:45, 0.0, and like I said, we're on a 4-hour shift off of UTC. So there's a start time, and then end time. We've got a couple different options with end time. Let's start with having an actual date time anchor. So 2020-08-05 T1546. Okay. And what we have come back here for each of these three tags is a series of all of the raw data values as an array for each of these. So let's start by looking at alarm. Notice there's no values inside of the array. That tells me that I did not have any raw data values for alarm inside of that time frame. So I was stagnant. That tag never changed. There was no values recorded in those in that time frame. But when I look to flow, I can see that starting right at 45 minutes past the hour, I had a value of 70. And as I go forward in time, I can see that my value went to 60 to 50 to 40 and so on. So as I'm counting up every second, it looks like I'm gaining in batches of, or losing, I should say, in values of 10. And now I'm gaining in values of 10. So some type of a triangular regression growth pattern here going on. Now, when I come down through all of that, I get down into my pump 2 status, and again, same thing, I had no value inside of that tag. All right, let's grow this window a little bit. We just did a minute. Let's go ahead and do something like 10 minutes. Let's call it again and see if we have any values for alarm or for status. There we go. So now our alarm had one value that came in, and it was a false value. And then as we go the whole way down to the bottom, we have our pump status that had a value of off as well that came in, and there's the timestamp. Now I could add another option here, and we could come in with a max size as well. So if I didn't want to have as many values return, we could come in and say, give me no more values than 20. And you can see it's been stopped. I still pick up at least a value for all tags that would have it. So where it cut off was on the pump 2 flow. And then there is my continuation points. If I would decide I wanted to pull the continuation, I could grab my continuation from this entire string, bracket to bracket. Okay, removing max size. Well, here, actually, let's leave max size at a little bit bigger. We'll say 50. Let's talk about relative date time. So instead of having that as my hard, fast end time, I could choose to use now. And now would allow me to run from this start time right up to this end time. In fact, if we remove max size completely, we can demonstrate what this looks like, because we'll have a much larger return sample. And that runs us right up to our current time. I've got 53 minutes past the hour currently. So every couple minutes, if I would call this again, my start time would stay anchored at 45 minutes past, and I would increase my population of samples, or my TVQs that returned. But if I wanted to just always get the last minute of samples, I could do something like now minus 1 minute. And now I'm going to always look back in time exactly 1 minute from when I make the call and grab all of the samples in the last 60 seconds. And this works for more than just now or 1 minute or 5 hours. In fact, if you look at the very bottom of the documentation page, you'll see all relative times so that I understand all of the different units that I can use: now, year, month, week, day, hour, minute, second, beginning and end, as well as some examples of what that might look like. this becomes a very helpful tool for grabbing specific time periods of data. Okay, let's talk about the aggregated functions now. We've talked about how to get the last data value as well as how to get raw data values. If we switch over and take a look at some aggregate functions, we can see some other options here as well. So we're going to shift this from now minus 1 minute to now minus 1 hour. In time is there, and now all we have to do is add an aggregate. And our aggregate here, if we look at our documentation, would be aggregate name. And what if we don't know what the aggregate names are? Then we use our get aggregate and make that request. Oh, did I lose my token? Okay, get aggregate request. There's my token. And there's a list of all of our aggregates, the actual name of the aggregate, and then what it does. Okay, so coming back, we could make our aggregate, forget tag data, let's make it time average 2. Now we have an aggregate, we need an aggregate interval. This simply means if we are looking over the last hour, what is our sample size that we want to run the time average 2 aggregate for? So let's go every 5 minutes. And I forgot my comma. I also forgot my quotes. And now for my alarm, I can see that I had a 2240 quality code coming back and a values of 0. Now I'm guessing that's because this is a serial. So again, I can get that quality and come and say, what is a, here, let me replace these. What is a 2240? And it's a good. So my aggregate is just returning a 0 because of a serial. So let's go ahead and we'll just drop this tag out completely. And there we go. With our flow, we can see that we had a good value coming back from the process, 150 for this 5 minute, 150 for that 5 minute, so forth and so on. So we had a time average of almost identical on that tag, and then our status coming back as null. Now what if we wanted to use a different aggregate? Let's look at total. Alright, so here I'm looking for the last 4 hours. I think my error before, the data didn't look right, is because I didn't have the S for hours. Important to note. Need that S on there for hours, as you can see in the documentation. I was just a result of my own sloppiness. So now we look at our total aggregate. Every 4 hours, or for a total of 4 hours every 5 minutes, I'm getting a total of all of my values. You could do the same thing with, for instance, a start. The start aggregate tells me the beginning value at the every 5 minute interval for the last 4 hours for that tag, or that collection of tags, I should say. Because if we come down about halfway, we can see, for instance, that we are off at 5:15, or at 15 59 minutes past the hour, which is our current time. All right, so that walks you through all of the ways that you can use get tag data. We should mention that the aggregate works with both the relative, just like the raw data, date, time, as well as having hard, fast date and time. So if I wanted to, I could have been pulling using relative, or I could have been pulling aggregates using start and end times. I don't think there's really any more parameters that we really need to go through at this point. Let's talk about live data and how this works. So in order to use live data, I'll show you a different look. Let's start with let's reestablish our connection. We've gotten our user token. Now let's get our live data token. For the live data token, we are going to pass our tags right here in this group. Okay, so when one of the differences is that when we establish a token with the get live data token, we need to pass the tags as part of that token. Okay, so we've done that. We've got a status code of good. Now with get live data, I don't really have any parameters here. Not like get tag data, it's different. With get live data, I'm really just running continuation, and that's my only parameter. So when I look at this, that's all I have. And what's going to happen is it's going to establish a series of values for me. And then as I delay, it's going to show me the new values since my last ask. So it's only giving me tags that have changes since the last time I asked. So I only got flows. Again, only flows. In fact, if I ask in fast repetitiveness, you'll see that I'm getting very few values. But if I wait 10 seconds, we can see that I'm getting a large batch of values for each of the tags. So that's the usefulness of the get live data, and why you would use it and how you would use it. There's the ability to revoke these tokens when I'm finished with them, and that's for both the live data token as well as the user token. I hope this was helpful for you. Would definitely recommend taking advantage of the documentation, which you can find at readapi.canarylabs.com, as well as from our help files. You can get here under the data connectors section of our help files. The last thing that's on here that we didn't cover was get ad hoc events. This is more of an advanced function where you have the ability to name a group of tags, define start triggers, and then ask for analytics around around the duration of the events that you're looking for. I would say that for this one, it's probably going to involve a separate video for us to go through that in a reasonable amount of time. You could also take a look at it here under the event methods calls for get events and get ad hoc events on your own, or look towards a future video. Thank you. Hope you have a great day. As always, if you have questions, email us, info@canarylabs.com.